At the end of the topic, you will be able to define matter, explain the physical state of matter, define and differentiate element, compound and mixture, list the characteristics of a mixture, define the purity of the substance, state the law of constant composition, give the composition of inhaled and exhaled air during respiration, give the composition of air, differentiate mixture and compound. The entire world around us is made up of matter. For example, the sweet-smelling fresh air that we breathe, the beautiful flowers and trees around us, the tasty fruits that we eat, the pets that we love, the roof and walls that make up our homes, the ground that we walk on, even our own bodies are all made up of matter. Matter is anything that has both mass and volume. Matter occupies space, that is volume. Some are large and some are small. The quantity of matter contained in any object is referred to as mass. Hence, each matter is characterized by mass and volume. All matter exists in any one of the three physical states: solid, liquid, and gas. Here is matter classification is based on two types. Based on physical state, it is of three types: solid, liquid, and gas. Based on composition, it is of three types: element, compound, and mixture. Physical states of matter. Solids. Solids have a definite shape and a definite volume. They take a lot of energy to change the shape. They are rigid and not compressed appreciably even at high pressures. They usually have high densities and expand only very slightly when heated. In a solid, the molecules are held tightly together in definite arrangements. Liquid. Liquids have no definite shape and they take the shape of the container. They have a definite volume. They are not appreciably compressed by moderate pressures. They expand more than solids on heating and changed into the gaseous state. They have lower densities than solids. Gas. Gases have no definite shape. They take the shape of the containing vessel. Gases have no definite volume. They have the property to fill the entire space available to them. They are easily compressed by even small pressures and also expand more than liquids on heating. They have low densities. A pure substance is a distinct type of matter that has the same physical and chemical properties throughout the sample. Substances rarely exist in a pure form in nature. Often they are mixed with many other substances or materials. Their physical properties and chemical properties are either changed or are not clearly visible because of the presence of other substances.
Click on the animation button to view the animation.
An element is a type of substance that cannot be broken down chemically. When an element is pure, the smallest unit of an element displays all the properties of that element. The smallest unit is called atom. These atoms exist as tiny little objects. Gases do not exist as single atoms. They exist as clusters, for example, hydrogen, oxygen, etc. Compounds are substances resulting from the chemical combination of two or more elements in a fixed proportion. The elements in compounds are chemically bonded to each other. The physical and chemical properties of such compounds do not resemble the properties of any of the constituent elements. For example, when hydrogen gas and oxygen gas are stored together in a container in the ratio 2:1, under certain conditions they combine to form water, which is a liquid and has physical and chemical properties that are totally different from those of either hydrogen or oxygen. Water is a chemical compound. A molecule can be broken down chemically into the atoms of the constituent elements. When two or more substances are mixed together and the substances retain their individual original identities, the combination is called a mixture. For example, if you mix sand and water, sand retains its own properties and water retains its own properties. In a mixture, two or more substances are brought together and no chemical reaction takes place. For example, if hydrogen and oxygen in any ratio are mixed together in a container gently at low temperatures in the absence of a spark, no chemical reaction would take place, and the mixture would display the physical and chemical properties of hydrogen and oxygen. The purity of a substance is determined by measuring its physical properties. A pure substance can exist as an element or compound. For example, a colorless, odorless, tasteless liquid, which at atmospheric pressure boils at 100 degrees Celsius, freezes at 0 degrees Celsius and has a density of 1.0 grams centimeter to the power -3, is water. The characteristics of mixtures are: mixtures may consist of substances with the same or different physical states. For example, bronze is an alloy consisting of the two solid metals, copper and tin. Both are in the solid state. Most common solutions are mixtures of a solid in a liquid. For example, salt dissolved in water. Mixtures are not pure substances because they do not display the same physical and chemical properties throughout the whole sample. In mixtures, atoms or molecules held together, but their individual physical and chemical properties are retained. In mixtures, elements are physically mixed in any ratio and no new compound is formed. The substances making up a mixture are called constituents or components. Types of mixtures. Solid in solid, example coins and alloys. Solid in liquid, example seawater. Solid in gas, example smoke, carbon particles in air. Liquid in solid, example amalgam, metal plus mercury. Liquid in liquid, example alcohol and water. Liquid in gas, example cloud, fog. Gas in solid, example gas absorbed by charcoal. Gas in liquid, example soda drinks. Gas in gas, air. Distinguish a mixture and a compound by performing the experiment below. Materials required: china dish, iron powder, sulfur powder, magnet. Procedure: take a china dish. Mix iron powder and sulfur powder in a china dish. In another dish, take the same substance and heat them strongly. Bring a magnet closely to the china dish. Iron powder has magnetic property. It attracts. But iron sulfide formed from iron and sulfide powder do not have magnetic property, so it does not attract the magnet. Iron sulfide is not showing the property of its constituents. Hence it is a compound, and iron powder and sulfide powder are mixtures. The lead in your pencil is actually a form of carbon called graphite, mixed with clay. Law of constant composition. A pure compound always contains the same elements combined together in the same definite proportions by weight, irrespective of its method of preparation. Is water a mixture or a compound? Water is a compound because of the following reasons. It is homogeneous. It has definite physical constants such as boiling point, freezing point, density, etc. The properties of water are entirely different from those of its constituents, that is hydrogen and atom. Water has a definite composition by mass. The ratio of H/O by mass is 1:8. Is air a mixture or a compound? Air is a mixture because of the following reasons. Air does not have a fixed composition. The composition of air varies from place to place. Artificial air can be made by mixing the various components of air in the same proportions in which they occur at a place. And when this is done, no energy changes are noticed. The components of air can be separated by a physical method such as a fractional distillation of liquid air. Liquid air does not have a definite boiling point. It boils over a range of temperature between -196 degrees Celsius and -183 degrees Celsius. If air is a compound, the composition of air expelled from humans should not be different from the composition of air around us. But it is known that during respiration, exhaled air has a lower percentage of oxygen than ordinary air. Composition of inhaled air and exhaled air during respiration. Inhaled air contains 78% nitrogen. Exhaled air contains 78% nitrogen. Inhaled air contains 20% oxygen. Exhaled air contains 16% oxygen. Inhaled air contains 0.03% carbon dioxide. Exhaled air contains 4% of carbon dioxide. Inhaled air contains very little moisture. Exhaled air contains appreciable amount of moisture. Composition of air. Gas, nitrogen. In mass, 75.50%. Oxygen 23.20%, argon 1.0%, carbon dioxide 0.046%, neon negligible, helium negligible. Classify the following into mixture or compound: alloys, smoke, juice, milk, common salt, coffee, carbon dioxide, ice cream. Tick the correct answer. Alloys, mixture. Smoke, mixture. Juice, mixture. Milk, mixture. Common salt, compound. Coffee, mixture. Carbon dioxide, compound. Ice cream, mixture. Difference between mixture and compound are listed in the table. Mixture. Elements are chemically combined in ratio and no new compound is formed. Compound. Elements are physically mixed in any fixed ratio to form a new compound. Mixture. They have no sharp or definite melting point, boiling point, density, etc. Compound, they have a definite melting point, boiling point, density, etc. Mixture, a mixture exhibits the properties of its constituent or component elements. Compound, property of a compound is different from its constituent or component elements. Mixture, they are either homogeneous or heterogeneous in nature. Compound, they are always homogeneous in nature. Mixture, Constituents of a mixture can be separated by physical methods like filtration, magnetic separation, etc. Compound. Constituents of a compound cannot be separated by physical methods. In this topic, you have learned a pure substance is a distinct type of matter that has the same properties, physical and chemical, throughout the sample. An element is a type of substance that cannot be broken down chemically. When two or more substances are mixed together and the substances retain their individual original identities, the combination is called a mixture. Compounds are substances resulting from the chemical combination of two or more elements in fixed proportions. A pure substance can exist as element or compound. In mixtures, elements are physically mixed in any ratio and no new compound is formed. The substances making up a mixture are called constituents or components. At the end of this topic, you will be able to classify the mixtures, explain the types of homogeneous mixtures, explain the types of heterogeneous mixtures, classify the matter around us, list few examples of heterogeneous and homogeneous mixture. When two or more substances are mixed together and the substances retain their individual original identities, the combination is called a mixture. Mixture of two types. They are homogeneous mixture, heterogeneous mixture. Homogeneous mixtures consist of a uniform distribution of substances throughout the mixture. For example, if samples taken from any part of the mixture, it will have the same ratio of the ingredient substances. It should show same physical and chemical properties, although the properties of different samples may be different. Air is a homogeneous mixture of nitrogen, oxygen, argon, and other traces of gases. Homogeneous mixtures are also called solutions. All the ingredients of homogeneous mixtures necessarily have to be in the same physical state. There are three types of homogeneous mixtures. They are solid homogeneous mixtures, example alloys, liquid homogeneous mixtures, examples alcohol and water, gaseous homogeneous mixture, example air. Activity 1. Aspirin is a medicine for headache. It is composed of 60% carbon, 4.5% hydrogen and 35.5% oxygen by mass, regardless of its source. Is aspirin a mixture or a compound? Aspirin is a compound. It is composed of carbon, hydrogen and oxygen, but it does not show the property of its ingredients. Heterogeneous mixtures do not have a uniform composition. For example, if you take dilute buttermilk in a vessel and keep it undisturbed at one place for some time, then the particles settle to the bottom and the water comes to the top. Ingredients of a heterogeneous mixture need not necessarily be in the same state, gas, liquid or solid. Types of heterogeneous mixtures: solid-solid heterogeneous mixtures, example mixture of sugar and salt; solid-liquid heterogeneous mixture, example ice cubes in water; gas-gas heterogeneous mixture, example smoke in the air; liquid-liquid heterogeneous mixture, example kerosene in water. Perform the experiment and conclude that whether the mixture is a homogeneous mixture or heterogeneous mixture. Materials required: ink, water, dropper, glass. Procedure: take a glass, fill it with water. Mix a drop of ink and water. Observe whether the color of the solution is uniform throughout or not. The color of the solution is uniform throughout. Therefore, the mixture is a homogeneous mixture. Perform the experiment and conclude about the mixture prepared. Materials required: spoon, sand, water, glass. Procedure: take a glass, mix a spoonful of sand in water in the glass. Try to see the particles of sand. Observe whether particles are evenly distributed in the mixture. Write the conclusion about the nature of the mixture prepared. Since particles of a sand are not evenly distributed and the sand settle at the bottom of the glass, the mixture is a heterogeneous mixture. Classify each of the following as homogeneous or heterogeneous mixtures: tea, ink, fruit salad, sugar solution. The answer is tea, heterogeneous mixture; ink, homogeneous mixture; fruit salad, heterogeneous mixture; sugar solution, homogeneous mixture. In this topic, you have learned there are two types of mixtures. They are homogeneous mixture and heterogeneous mixture. Homogeneous mixtures consist of a uniform distribution of substances throughout the mixture. Air is a homogeneous mixture of nitrogen, oxygen, argon, and other traces of gases. Heterogeneous mixture do not have a uniform composition. Heterogeneous mixture need not necessarily be in the same state, gas, liquid, or